Assalamualaikum warahmatullahi wabarakatuh. I'm Haikal from Group Abdullah and this is my groupmate, Malik and Zaidi. For this video, we want to share with all of the viewers who is watching to this video right now about related rates. What is related rates? Related rates are calculus problems that involve finding a rate at which a quantity changes by relating to other known values whose rates of change are known. For instance, if we pump air into a donut floater, both the radius and the balloon volume increase, and their growth rates are related. Both can be solved, but it is much easier to solve the volume rates of change. Take note that the related rates of change are generally expressed in terms of time. Besides that, related rates problems can be solved by two ways, which is implicit differentiation and chain rule. However, there are some problems we need to use both of ways to solve them. What is differentiation? In mathematics, differential calculus is a subfield of calculus that studies the rates at which quantities change. It is one of the two traditional divisions of calculus, the other being integral calculus, the study of the area beneath a curve. To understand more deeply about this, let's see how its calculation in the form of graph and equation. From the graph, we could see that the blue line is a secant line and the red line is a tangent line. We know that equation of a straight line is y equal to mx plus c. So, based on this equation and the graph, we can make an equation for tangent line. Y minus function x naught equal m tangent times x minus x naught. Then, from this equation, we need to express m tangent in terms of function x minus function x naught divide with x minus x naught. From the equation we have made, we need to provide limit like the equation 1. And from the equation 1, we can rewrite the equation in terms of x naught and h as m tangent equal limit h approach to 0 function x naught plus h minus with function x naught divide with h, like equation 2. Assume that the function f(x) exists, then the derivative of the function f at x is given by like this. This equation is called the first principle of differentiation or the definition of differentiation, also called the derivative of f with respect to x. Overall, this is the meaning of the differentiation. However, for the topic we want to share with all of you only using the simple differentiation. For example, if y equal x power of 4, dy over dx equal 4x cubed. If y equal to x power of 4, dy over dx equal 8x cubed. If y equal x power of 5 plus 2x power of negative 3, dy over dx equal 5x power of 4 minus 6x power of negative 4. When do we apply differentiation? We apply differentiation when we try to find the maximum or minimum number of the values. Also, when we try to find the rates of change of the values. When we do integration, also need to apply differentiation, but only for certain equations. What are other applications of differentiation? Analysis of function 1, increase, decrease, and concavity. And analysis of function 2, relative extrema, first and second derivatives test.
So, the problem statement is an airplane is flying overhead at a constant elevation of 4,000 feet. A man is viewing the plane from a position 3,000 feet from the base of the radio tower. The airplane is flying horizontally away from the man. If the plane is flying off at the rate of 300 feet per second, at what rate is the distance between the man and the plane increasing when the plane passes over the radio tower? For the objective, there is three objectives. To find the rate of distance between the man and the airplane increasing when the airplane passes over the radio tower. Second, to find the distance between the man and the tower with Pythagoras theorem. And lastly, to solve the question by using the related of rates method.
Next, for problem solution, step 1. Draw the problem into a figure as shown in figure 1.0 to make things easy to understand. This is the formula we are using for related rates. dx over dt is equals to dx over ds times by ds over dt. The given speed of the plane is 600 feet per second, which makes dx over dt equals to 600 feet per second. Since we are asked to find the rate of change of distance between the man and the plane when the plane is directly vertically above the radio tower, that leaves us to find ds over dt when x is equals to 3000 feet. Next, step 2. From figure 1.0, we can use Pythagorean theorem to write an equation relating x and s. The equation is as such. Next, step 3, we will differentiate the equation with respect to time. And we'll get x times dx over dt is equals to s times ds over dt. Step 4, we'll need to find the value of s. So we're going to use Pythagorean theorem based on figure 1.0. 3000 squared plus 4000 squared is equals to s squared. And after a few calculation, s is equals to 5000. Next, step 5, we can now substitute the values into the equation before. X times dx over dt equals to s times ds over dt. X is 3000, dx over dt is 600, s is 5000, and ds dt is the one we're going to find. After a few calculation, we'll get ds over dt is equals to 360 feet per second. The rate of change of distance between the man and the plane when x is 3000 feet and the plane is directly vertically above the radio tower is 360 feet per second.
So, in conclusion, we can find the objective of the question that asks for the distance between the man and the airplane is increasing when the airplane passes over the radio tower. In the other hand, we can solve the problem statement by using the Pythagoras theorem and related of rates method. There is two references we get. First for the question and second reference to solve the problem. So, that's all from me. Thank you.